Dear students, welcome back to our channel. In the previous class we have discussed some problems on the topic integral as the limit of the sum in the chapter Riemann Integral. Today also we will discuss some more problems on this topic. Previous lessons will be displayed in the description box. Those links I will provide in the description box so you can go through the previous class also. Today we will see some more problems. Evaluate limit n tends to infinity 1 by n plus n square by n plus 1 whole cube plus n square by n plus 2 whole cube plus and so on plus 1 by 80n. We have to evaluate this. Given limit. Limit n tends to infinity 1 by n plus n square by n plus 1 whole cube plus n square by n plus 2 whole cube and so on 1 by 80n. This is the given limit. Now I will write this as limit n tends to infinity n square by n cube. I write this 1 by n as n square by n cube because when we observe the numerator contains in all the terms n square. So that is why I have written first term also 1 by n as n square by n cube. This is n square by n plus 1 whole cube. N square by n plus 2 whole cube. N square by n plus r whole cube. N square by n plus n whole cube. N plus n is 2n. 2n whole cube is 8n cube. On cancel n square 1 by 8n. So 1 by 8n we write down as n square by n plus n whole cube. Now limit n tends to infinity. Now this sum of the terms we write it as summation sigma n square by n plus r whole cube. Here r is varying from 0. We write this n as n plus 0 cube. So r is varying from 0 to n. Now limit n tends to infinity. Sigma r is equal to 0 to n square by, we take n as common, 1 plus r by n. N common, n into 1 plus r by n. Whole cube is remaining. Now we have to write on both these terms. Cancel n square. We bring 1 by n outside this sigma. Limit n tends to infinity 1 by n sigma r is equal to 0 to n 1 by 1 plus r by n whole cube. Now we replace r by n by x 1 by n by dx and limit of the sum sigma r equal to 0 to n by integral 0 to 1. In the previous class we have discussed. So we replace r by n by x 1 by n by dx. Limit of the sigma is integral 0 to 1. Now we convert this limit of the sum into integral. Integral 0 to 1 by 1 plus r by n is replaced by x whole cube. 1 by n is replaced by dx. Limit of the sum is replaced by integral 0 to 1. Now we have to integrate 1 by 1 plus x whole cube. As we all know, integral 1 by x cube dx is equal to minus 1 by 2x square. So plus c, it is indefinite integral. If you take integral 1 by x cube is minus 1 by 2x square. Now this is equal to minus 1 by 2 into 1 plus x whole square. Integration over. Now we have to apply limits. By using the fundamental theorem of integral calculus, we write down upper limit minus lower limit. Now minus 1 by 2 into 1 plus 1 whole square plus 1 by 2 into 1 plus 0 whole square. Upper limit minus lower limit. Already there is minus, no? So minus into minus plus. So we got minus 1 by 1 plus 1 2. 2 square 4. 4 into 2 8 plus 1 by 2. 1 plus 0 whole square is anyhow 1. So 1 by 2. Now taking LCM, minus 1 plus 4. So that is equal to 3 by 8. 3 by 8 is the answer for this question. Limit n tends to infinity 1 by n plus n square by n plus 1 whole cube plus n square by n plus 2 whole cube plus so on 1 by 8n. So the answer of this limit is 3 by 8. See second problem. Find the limit of n factorial by n power n whole power 1 by n when n tends to infinity. We call this limit as A. A is equal to limit n tends to infinity n factorial by n power n whole power 1 by n. I will write it as limit n tends to infinity n factorial 1 into 2 into 3 into 4 into 5 into up to n by n power n, we write it as n into n into n into n into n times power 1 by n. Limit n tends to infinity, we write this as 1 by n into 2 by n into 3 by n into n by n. So like this we have changed the given problem. First we have considered this limit as A and we convert n factorial as 1 into 2 into 3 and so on n power n as n into n into n into so on n. Now we have splitted limit n tends to infinity 1 by n into 2 by n into 3 by n into n by n. Now we take logarithms on both sides. Take log on both sides. Log A is equal to log limit n tends to infinity, we bring it outside, log of 1 by n into 2 by n into 3 by n and so on n by n whole power 1 by n. Already we know log of a power m is equal to m into log a, and we also know log of a into b is equal to log a plus log b. Similarly, log of a into b into c is equal to log a plus log b plus log c. So using these two, we convert this limit n tends to infinity. First we consider this as log of, this is a, log of a power m, we write it as m into log a, m into log a. Log a means this. So log of a into b into c into d, we write it as log a plus log b plus log c, like that. Log a plus log b plus log c and so on plus log n by n. So we have used these two formulas in logarithms simultaneously. At a time we have used these two formulas. Now log a is equal to limit n tends to infinity 1 by n. Now we write this summation sigma log of r by n. We write down rth term. First term is log of 1 by n, second term log of 2 by n, third term log of 3 by n. In between we have rth term log of r by n. Nth term is log of n by n. Here r is varying from 1 to n. So r is varying from 1 to n. So as we have discussed earlier, r by n is replaced by x, 1 by n is replaced by dx, and limit n tends to infinity sigma r is equal to 1 to n is replaced by integral 0 to 1. Now we use all these terms. Log a is equal to limit of sum is replaced by integral 0 to 1. Log r by n is replaced by x, 1 by n by dx. Now we have to integrate this now. Log a is equal to, on integrating log x, we will get x log x minus x. Integration over. Now limits 0 to 1. Now by using fundamental theorem on integral calculus, upper limit 1 log 1 minus 1, on substituting 1 in place of x, 1 log 1 minus 1 minus, this is upper limit, 0 into log 0 minus 0, this is lower limit, upper limit minus lower limit, log 1 is 0, 0 into 1 0, so we got in this bracket minus 1, 0 into something 0, 0, so we got minus 0, so log a is equal to minus 1. Our target is to find out a. We call this limit as a, no? So that is our aim, to find out a. We have to remove log on both sides. So we take this as a log e. Anyhow log e is 1. So therefore a is equal to e power minus 1. This is equal to 1 by e. Therefore a is equal to 1 by e. Therefore, the limit of n factorial by n power n whole power 1 by n as n tends to infinity gives 1 by e. Therefore, limit n tends to infinity n factorial by n power n whole power 1 by n equal to 1 by e. The third problem. Evaluate limit n tends to infinity 1 by n into sine pi by 2n plus sine 2 pi by 2n plus sine 3 pi by 2n and so on sine pi by 2. This is the question. The given limit is limit n tends to infinity 1 by n. Here the first term is sine 1 pi by 2n. Second term sine 2 pi by 2n. Third term sine 3 pi by 2n. 2n is common when we observe. 2n is common in all the terms. Rth term is sine r pi by 2n. Nth term is sine n pi by 2n. Anyhow n cancel and pi by 2 will be remained. So like this, I have converted the given problem. Limit n tends to infinity 1 by n sigma, we write down rth term sine r pi by 2n. Whereas r is varying from 1 to n. Now as usually we replace r by n by x, 1 by n by dx, limit n tends to infinity sigma r is equal to 1 to n by integral 0 to 1. So integral 0 to 1 sine r by n, no, we have to replace this by x. Sine pi by 2 into x. 1 by n we have to replace it by dx. Here upper limit is n, no, so we have to take 1 as discussed earlier. Here if it is 2n, integral 0 to 2. If it is 10n, integral 0 to 10. Like that we have to change. Now we have to integrate. Sine pi by 2 integral is sine pi by 2 into x. The integral is cos minus cos pi x by 2 by pi by 2. So on integrating sine nx, we will get minus cos nx by n plus c. So using that formula, integral sine nx is equal to minus cos nx by n plus c. Using this formula, we have integral 0 to 1 sine pi x by 2 is minus cos pi x by 2 by pi by 2. We have to substitute now limits. We can bring this constant term outside the bracket. Pi by 2 will taking on reciprocalizing, minus also we bring it out, minus 2 by pi cos pi x by 2. Now by using again fundamental theorem, upper limit minus lower limit. Upper limit cos pi by 2. In place of x we have to write upper limit minus cos pi by 2. We replace x by 0, lower limit. Upper limit minus lower limit. Now this is equal to minus 2 by pi into cos pi by 2 minus cos 0. Minus 2 by pi cos 90 0, cos 0 is 1. minus 2 by 2 minus 2 by pi into minus 1 is 2 by pi. This is the answer. 2 by pi is the answer for this question. Hope you understood all these problems and previous class problems also. I will provide the links in the description box. You can go through. Hope you understood. Thank you.